In this video, we're going to determine congruent angles in similar triangles. We're going to set up proportionality statements of similar triangles, and we're also going to learn the rules by which two triangles can be proven similar. So let's start with our first set of problems, which asks us to list the pairs of congruent angles and write the statement of proportionality. They already tell us the triangles are similar, so what we know is that the corresponding angles are congruent. We would say angle M is congruent to angle B. Angle T is congruent to angle Y. We know this by the two arcs there. And also angle N is congruent to angle X. The way we set up a proportionality statement is by comparing our image to our pre-image. We're going to say that triangle MTN, you could choose a different order if you'd like, but all you have to do is ensure that the M matches with the corresponding angle here, the T matches with the corresponding angle there, and the N matches with the corresponding angle there. The corresponding angle with M would be B, T corresponds with Y, and N corresponds with X. And the second question, our congruent angles would be angle C is congruent to angle B, angle D is congruent to angle E, and if you notice, both triangles share angle A, so by the reflexive property, angle A is congruent to angle A. Our statement of proportionality, again, you can set up the letters in any order as long as the corresponding angles match. I'm going to say triangle A, B, D, starting with the smaller one, matches with or corresponds with triangle A, C, E. In our third set, angle G is congruent to angle L, angle H is congruent to angle I, angle J is congruent to angle K. Proportionality statement, H, G, J is proportional to triangle I, L, K. When comparing two triangles, we're going to use the triangles to the right to answer these questions. They're saying triangle TIR is similar to, well, if they're saying TIR, we have to go with A, G, N in the same order. The next question, number 5, asks us TI corresponds with which side? TI is this side, corresponds with AG. IR, being this side, corresponds with GN. And RT corresponds with NA. Now they're asking us which sides correspond. 24 actually corresponds with the 16 side. And which side corresponds with the 10? That would be our X. They're asking us which side corresponds with the 24. That would be 16. And 12 corresponds with our Y. Over here, on question number 8, it asks us to solve for X and Y. We're going to take question 6. 24 over 16 equals X over 10. What we would do is do 24 times 10, which is 240, equals 16x. Divide both sides by 16. And x equals 15. For our y, we take this proportionality statement right here. 16 over 24 equals 12 over y. We take 24 times 12, 288 equals 16y. Again, we divide by 16. Your answer here would be y equals 18. Now, in order to do the next section and determine whether the triangles are similar, we have to take a peek at two ideas behind this. The two rules for determining if some triangles are similar is to use our angle-angle theorem. That states that if two angles of one triangle are congruent to two angles of another triangle, the two triangles are similar. You can take this one step further. If you say two angles in one triangle are similar, are equal to two angles in another triangle, you can assume that the third one would also be congruent. Our side-side-side theorem says that if the three pairs of corresponding sides are all proportional, then the two triangles are similar. Now, what we have to make sure is that when we compare and set up a ratio, that all three sets of corresponding sides have an equal proportionality or ratio. Let's look at this triangle right here. If you notice, we have isosceles triangles. If this base angle is 71, this angle is also 71. To find that third angle, you add 71 and 71. That's 142. Then that angle would be 180. Take away 142, which gives us 38. This angle over here is 38. To figure out one of the base angles, you take 180, take away 38, which is 142. You need two angles, so you got to cut that in half, and your answer is 71. If you notice, two angles here match with two angles here. Yes, they're congruent by angle-angle. On number 10, if you notice, we do have a right angle in both of these. However, there's no markings in here or here to show us that it's congruent with the 30, so we don't have enough information. So we just say not enough information. On number 11, what we have here is two equilateral triangles. If you remember about equilateral triangles, all the angles in equilateral triangles are 60 degrees, which means we have angle-angle. Yes, they're similar by our angle-angle theorem. Moving on to number 12. Based on the fact that we have a line here, and we have one right angle, this other angle must be 180 minus 90, which is 90. In order to find this third angle, angle A right here, I would do 62 plus 90. That gives me 152. If I take 180 minus 152, then I get 28. No need to go any further. I have this angle is congruent to that angle, and my two right angles are congruent. We have another angle there. Number 13 and 14 deal with parallel lines. So if I have two parallel lines, I know that by the triangles or the arrows, extra set of arrows there. And if it's cut by a transversal, that means that angle W is congruent to angle V, based on alternate interior angles. And likewise, if you look at the opposite transversal here, going through x and z, these are also congruent based on alternate interior. And what we also see at angle y are vertical angles. So based on any of those sets of information there, we do have two pairs of congruent angles that correspond. Angle, angle, yes, they are similar. Number 14, again, we're dealing with parallel lines because we have these extra arrows there. This one's a little bit different. We have two parallel lines cut by a transversal here. However, these two angles are not alternate interior, they're corresponding. If I cover this up right here and I take these two parallel lines cut by this transversal, these are also corresponding. You really don't need to know any further information. However, we do know that S is reflexive, a reflexive angle on both triangles, but we don't really need that information because we already have two pairs of angles. So it is congruent, or excuse me, similar by angle, angle.